Hi, thank you for tuning in for a simulation webinar. My name is Julio Calles and I am an application engineer here at DesignPoint. At DesignPoint, we love SolidWorks, we love everything about 3D, and we love our customers. Let's see what I have on today. So first we'll be conducting a topology study. A topology study is a powerful tool that comes with the SolidWorks Simulation Suite. If you have SolidWorks Simulation Professional or SolidWorks Simulation Premium, you can use this study. It will help you find the optimal structural shape of your design. For this example, I will be using a linkage arm. The linkage arm is actually part of a rear shock absorber and is mounted in a mountain bike. There are three goals that you can set up when using a topology study. You can do a minimize the mass, or perhaps you would like to increase the stiffness. Last, you could also reduce the maximum displacement of your model. As far as the loads that we're going to be utilizing, I have a side load, a full load, and a rest load. The side load will try to simulate someone riding the bike and hitting a rock. The full load will simulate when the rear shock absorber is fully compressed. And the rest load will simulate the rear shock absorber at its rest state. Finally, once we obtain the results, we'll end up with a non-parametric component. So we'll have to make a couple tweaks in order to use them. You'll have three options to export your body. We'll take a look at them. What I'd like to do next is go ahead and jump into SolidWorks. As you can see here, we have our linkage arm. I will now go through how the part was created. So let's go ahead and take a look how to activate the simulation tool in SolidWorks. If you come in over here on the top, you'll see that you have several add-ins. This is a very nice way that the software can help you organize your interface. I'll select SolidWorks Simulation. As I do that, you will be able to see that I have several studies set up. Let's take a look at the study tree. I have a full load, a rest load, a side load, and a combined load. I went ahead and I ran all of these studies ahead of time. Let's take a look at the stresses for the linkage arm under the full load study. Here, the software will be able to give you sort of a good picture on how your part will deform based on the loads applied. Please pay close attention that the image that you're seeing does have a deformation scale. We can take a look also at the displacement. And why not? Let's animate it. You can animate it by right-clicking on the displacement plot and selecting Animate. Let's take a look at the rest load study. We can see the stresses, the displacement, and let's also animate it. It can dance. Alright, let's take a look at the side load. Well, I tell you that I have never seen that dance. And finally, I actually set up a study which will have all of these different loads combined, almost like simulating a worst case scenario. You can see by looking at the legend that the maximum displacement happens in this region. Alright, enough, right? Let's take a look how to set up this topology study. So the first thing that I'm going to do is I'll come here to the top and I'll select New Study. Once again, you'll be able to use a topology study if you have SOLIDWORKS Simulation Professional or SOLIDWORKS Simulation Premium. Let's take a look. So we have different categories. We have general simulation, we have design insight, we have advanced simulation, and we have what is called specialized simulation. Our topic for today is using the topology study, which can be found under the design insight category. I'll call this one our simulation webinar. Let's click OK. Alright, as you can see, our study tree has slightly changed. We have our parts, connections, fixtures, external loads, golden constraints, which is new, and manufacturing controls as well. Now, if you have SOLIDWORKS simulation, the software does help you to become efficient, even when conducting simulations. Let's take a look. If I click on their combined loads, you'll be able to see that we have all of the parts, fixtures, and external loads attached to that simulation. Well, did you know that you can simply drag and drop the settings from one study into the other? Just simply left click and drag and drop it from one study into the other. I'll do the fixtures as well, and I'll do my external loads. Before I continue to jump into the topology study, I'd like you to take a look at the load definitions. So we have 8,000 newtons of force acting on these faces. We've also selected the direction of the force as well. I hit cancel. Let's take a look at the full load center. For this one, I did a remote load. Let's take a look at rest load. This one is also happening on those faces. And we have selected a direction as well. Then we have the rest load center for the wheel fixture. And we're also utilizing a remote load. I have my side load as well from the wheel and the side shock fixture. All right, usually what I like to do is run all of my studies ahead of time, just like I did. If you need to run more than one study without having to do it manually and independently, this is what you can do. If you come here under the Simulation tab and you click the bottom arrow under Run this study, you can select Run all studies. If you do that, the software will go ahead and it's going to run each study independently, but it'll do it one after the other. Let's jump back into the topology study. Remember, I called it a simulation webinar. Once I copy the settings from the combined load study, you can see that now I have my material, which is 1060 alloy. I have fixtures, and I have all of the external loads which were successfully copied. Let's take a look at the next settings. All right, for the next settings, I will go ahead and add some goals for constraints, and I'll be utilizing minimizing mass. That will be one of the overall goals for my design. Let's take a look. The first one, I will go ahead and use the displacement constraint. For this one, I'll specify a factor of 1.3. We want to eliminate as much mass as possible, but we want to ensure that the maximum displacement does not exceed 1.3 times what it would be without any material. Next, I'll go ahead and use the stress factor of safety constraint. Here, we'll specify 90%. This is going to help us ensure that the maximum stress does not exceed 90% of the material yield strength. Lastly, I'll add one more. I will also go ahead and add a mass constraint. Let's take a look. Here, specify to reduce mass by 50%. Let's select OK. Next, the software will give you the ability to select different manufacturing controls. You can add preserved regions, you can specify thickness control, you can specify the mold direction, or you can specify a symmetry plane. I'll go ahead and select the bottom two. We'll start with the symmetry. I want to ensure that towards any type of material that is removed, the software does understand that the part is symmetrical. I'll select the right plane, and that will be our first symmetry plane. Let's hit OK. Last, I'll add the mold direction. This is going to help the software understand that the part should be manufacturable. And also, it should be easily extracted from a mold. I'll select this edge as our pull direction and hit OK. Alrighty, we're almost done. Now, since we are going to be using multiple loads, I'll have to set up a little bit of a trick on this one. To do that, I'll actually set up load cases. I'll come here and right click under the simulation webinar study and select multiple load cases. We'll select OK for that message for now. Alright, so what I'd like to do is start and set up all these different cases. We'll have one which we'll call full load case. Then I'll have a second one which will be the rest load case. And finally, our side load case. Alright, so as you can see, all of them are initially suppressed, but you can begin to unsuppress them. It's gonna be a few clicks. Okay, and then what I'm going to do, I'm going to use the restore window. That way you can see the settings that I'm doing. So I'll bring it here. A little bit up. Okay, I hope you can see there. Okay, so I'll pardon me, unsuppress the rest load. Do this one here as well. Okay, and lastly I'll do the side load. One more, and we're done. Here we go. Awesome. Looking good. Lastly, since we're doing multiple load cases, I'll come here to the properties, and I'll use the min and max formulation for load cases. I'll make sure the box is checked and I'll hit OK. The next step you would like to do will be to create a mesh. Let's right click on the mesh and use create mesh. Now, I am using SOLIDWORKS Premium 2020. You can see here I can easily change my mesh quality. I can choose between high or draft quality. I'll bring it to draft quality, and it's only to reduce some of the computational time. I'll come back to the definition, and I'll make sure that I'm using a curvature-based mesh. I will go ahead and leave these settings by default. Let's select OK. You can see that the software is able to successfully mesh our body without any issues. What I'd like to do next is that I am aware that this study does take a few minutes. So I will pause the video for now, I'll let it run, and then we'll come back to it. See you soon. Welcome back. I'm feeling a lot older for some reason. All right, so let's take a look what the software provides you. So it does give you a legend on the right, letting you know which material can be kept and which material is okay to be removed. Now, once again, this is given the boundary conditions that you gave the software. So let's right click under the material mass plot that has been created. I'll select edit definition. Here you'll be able to tell the software how much material you would like to do. Perhaps you want to do on the lighter side, or perhaps you want to come in the heavier side. Okay, we have obtained about 50% of the original mass. I'll select calculate smooth mesh. And here you can choose between coarsen or perhaps smooth. Once you select and play around with the settings, you can select, bring this down here for a second, and I think I'm seeing it yet. Okay, believe we should be okay. Advanced, smoothing options, properties. All right, awesome. So I'll select OK. And the next one is to export this body. I'll right click on it and I select export smooth mesh. Sorry. You can choose to save it under your current active configuration, perhaps under a new configuration or a new part file. If you choose to save it as a new part file, you can specify the name. By default, the software will try to name the simulation study. So let's go ahead and tell it where we want to save it. So you can go ahead and decide it, which location on your hard drive you would like to save it. I'll hit cancel because I actually have saved mine already. So let's take a look what you can do with this. Okay. Now, many of you will probably mention that this is perhaps only used for additive manufacturing process. I could agree, but I could also say that you can, now with this type of model that you use it to make certain changes, right, to your primary model and almost achieve the same goals. For example, I'll show you my finished model. You can see here that I did different cuts and I use many of the different features that the software provides you to work around with this model. Remember that you will begin with a non-parametric shape. Let me see if I bring this all the way back. I think we'll be able to see it. Yes, let me actually show the other body. And I'll hide the other one. Right. This is almost what I began with. What I did is that I placed it on top of my primary body and used the geometry to make cuts as necessary. Okay, I hope you have enjoyed the simulation webinar. Thank you for tuning in, and I hope you have a wonderful day. And remember, more is possible, especially with SOLIDWORKS. Have a nice day.